Hi all. In this section, we will discussing about plugger solenoid in detail. Okay. In last class, we have discussed about this solenoid. In that, we have detailed the dynamic and static characteristics of the same. And today, now we are going to discuss about plugger solenoids and what are plugger solenoid. And in the first class, I have demonstrated about the inside part of a plugger solenoid. We have investigated that and about the plugger solenoid, and this is the structure of a plugger solenoid, and it have a housing section. It have a coil, and it consists of a plugger stopper, and obviously we can say that it should have a plugger section that should be the movable part. And here also some air gap will be there, and that air gap is leading for the movement of the device or movement of the plugger in the system. Okay, and let's go in detail about the plugger. And this is the constructional structure of the plugger solenoid. And as a point, when we are discussing about the plugger solenoid types are most popular solenoid configuration with a varieties of application. We can say for the plugger solenoid, and this is because of the plugger solenoid's configuration has a single main air gap for flux to cross and one parasitic air gap that is usually perpendicular to the main one. That means when the coil is excited from the external voltage and it produces electromagnetic fluxes, and that fluxes should be perpendicular to our plugger, and that plugger, and due to the uniform air gap in the plugger with a plugger stopper, this is possible for applying different application, or we can easily embed this device in a different application. And the inner pole surface of the main air gap carries the flux that perpendicular to its surface, and especially at the same small air gap where the flux crossing parasitic air gap does not contribute to the axial force. And in most of the cases, when the parasitic air gap is even around the axis of symmetry, and this, then this entire force may get cancelled out due to the when your system is demagnetized, on when you are changing the voltage that we are applying to the device, then automatically it comes to the normal position. And did promote the application which small travels and fast actions such as injectors and other fast acting solenoids. And in the case of disc armature or disc solenoid that we have discussed in the last class, and that applicability is also should be the same for in the case of plugger solenoids. Okay, and moving to the next slide and going into the deep for the static characteristics of the solenoid. And these are the static characteristics of the solenoid. And in this, the achieved voltage has increased based on the time. The flux, in the case we have discussed in the case of this solenoid, flux is changing based on the applied voltage, and it rising it into the maximum and comes down gradually when you are removing the voltage. As well as current also, it's going at the maximum, then falling to the not minimum up to the point, and then it's hacking to the high position and leaving to the normal position. And in the net force is applied or generating inside the system is going falling at the negative axis of the graph, and due to the movement of the entire device as well as the negative current generated to the inside the system due to the change in the architecture. Okay, and the spring force also acting on the acting inside the system, and that should also be can considerable when we are considering the characteristics. Okay, and moving to the next one, this is the dynamic characteristics of the device, and when we can say the plugger, how the plugger is moving when we are applying the external voltage. And now initially we can investigate that, initially we can analyze that some kind of air gap is present in between the plugger and the plugger stopper, And when we are applying, at the moment we are applying the voltage, then the coil will generate the magnetic flux. That magnetic flux influencing this plugger to move towards the plugger stopper. And if we are applying the voltage at 1 millisecond, when we can consider after 1 millisecond, the flux should be like this. The moment, the position of the plugger like this, there should be some air gap. And at the 2 millisecond, after applying the voltage, when we can say the 2 millisecond, the plugger is moving towards the plugger stopper and the air gap is reducing. And here also at flex at the C, flex at 3 millisecond, the air gap is reduced, and we can this should be a negligible air gap. And fully in the D, the flex at 4 millisecond, we can say the flex is contributing in the system at very high. It is not in the case of first case, but moving to the last case, the flex linking the system at the maximum, and the air gap is reducing into zero. And these are the dynamic characteristics of the device. We can say the flex is how affecting the flex inside the system to move the plugger to the plugger stopper, or move towards or forward in the system. Okay, and that's all about this plugger solenoid, the static and dynamic characteristics when we are going in deep. Okay, thank you.